Modified Fuji jewel teeth. This is you can see I'm using the Fuji circuit board and trying to make a sleigh exciter. The draw is less than a milliamp. That is about 0.39 milliamp, which is about 372 microamperes. Right, there's a port here. I'm running right now a CFL on 1.5 volts. You can 1.5 volts. Let me just stick this down. You can hear a buzz there. Once this is taken out, yeah, CFL doesn't light up. Okay. Let's light up the CFL again. So you can see 1.5 volts here, running at less than half a milliamperes, 220 volts, 22 watts. You can see, if I were to connect this to this in series, this is LED 240 volts. Right, lights there. The draw has gone down to about 320 microamps. Yep, and I can dial this further down. Right now I can dial it down to, see I'm dialing it, you can dial it down to like that. Yeah, very low, running about 114 microamps. Dial it further down, like real low. Now what's that? That's real low. Two of them in series, one of them almost off. 76 microamps. Right, if I reduce the resistance, and look at the brightness of that. Oops, it's about 1.2 milliamps. The full brightness is about 1.2 milliamps. Not too bad. 1.2 milliamps for 240 volts in series. That's 480 volts running off of Fuji. My next project is to basically hook up the Tesla sleigh exciter and run some fuel. Okay, just made an Evermanco plug, a very interesting plug, just to show you the high voltage. Basically, this is two diodes connected in one direction. That's in line with the LED. You can see high voltage here. Right, I don't know whether I can see. Yeah, no, yeah. High voltage is there. This is high voltage. Let me just poke this pin properly. Right, high voltage. Right, you can see it's about probably about 400 plus volts going through my body. You can hear the frequency, is it? Right, it's high frequency, high voltage, low current. High frequency probably above, if I can hear it audible, maybe it's about 30,000 kilohertz, 20,000 kilohertz. Sorry, 20,000 hertz, 20 kilohertz. Alright, I can feel a little bit of tickling sensation at 1.5 volts. You'd be surprised. Very tiny tingling sensation on my finger, very tiny. It's running 1.56. Let me just dial it down. Okay, Evermanco plug. You can see even on the power supply, it's pulsing. High voltage is going through the power supply. Yeah, this is just an antenna. 2 for 1 for 8 diodes there, blocking diodes basically. You can see the high voltage is punching through the battery. Right there you see high voltage. Everything that this thing touches, you can see high voltage. The next step is basically to have a feel around here. So especially on a hot wire, the hot green one here, so that then connect to a Tesla, so that when this plug is nearby the battery here at 1.5 volts, you see the fuse. Probably I'll bump it up to 3 volts. You can see a fuse, i.e. you can see the fuse that's coming from there. Right, for now, let me dial back this again to, when I dial it down a little bit, you can hear the frequency, the buzzing away. So if you have probably it won't pick up on the radio. I have to figure out how do I go to the megahertz range. You can see it's drawing like, wow, this is like, goodness, 56 microamperes. We have this guy is almost out. Nah, he's out. This guy is still alive. Let me just dial it down as little as I can. As little as I can. I don't know, do you see that? Nah. Okay, let me try again. Dial it down. Okay, this is nothing. This is like, yeah, okay. Yeah. 33 microamps. And if I get a very low current diode LED, probably I'll be able to use this to detect anything that is maybe under a volt here. Next thing you can see, I'm trying to figure out is whether crystals like this would be able to produce a battery. Next one is to build the sleigh exciter. After that, do a solar charger, so that we'll have a lidmotor has a project called Forever Light, and I'm motivated and inspired by Forever Light. Basically get free electricity to run lights like this. Thanks for watching. Keep experimenting. Bye.